Hello and welcome to a new term of class time.
For this term, we will be focusing solely on mathematics and English.
And we will only be on for 1 hour, so make sure you get here on time so that you don't miss a thing.
And as usual, there are many ways you can keep up with us. You can join us live here on TVJ or on One Spot Media.
And if you need some clarity on something we've taught today, you can send your questions to our various social platforms.
I am Tyrone Brown.
And I'm Nikisha Hardy. And today we'll be reviewing numbers. Let's get started. All right, so the focus of today's session will be order of operations, rounding off, looking at decimal places and significant figures, as well as simplifying fractions. Let's begin with order of operations. Now, why is this important? Now, the order of operations tells us how to do a math problem with more than one operation in the correct order. And that is very important because if we do not follow this order, we'll all get different answers. So let's see the order that we're supposed to conduct our operations. So we have heard of the acronym PEMDAS. And to make it easy for us to remember, please excuse my dear Aunt Sally. Now the P represents the parentheses, which we call brackets. The E, exponents or roots. M for multiplication and D for division, and A, you guessed it, addition, and S, subtract.
But wait, Nikisha, I'm seeing something strange. I'm seeing that the M and the D are grouped together in one circle.
Yes.
And the A and the S are grouped together in another circle. Can you tell me a little bit more about why that is?
Sure, and I'm glad you mentioned that. Good observation. Now, multiplication and division. They're saying that these operations can be done depending on which one comes first. And remember, for them, we'd operate from left to right.
Okay.
So in a problem, if we see multiplication and division, if division comes first, we can work the division first, and then the multiplication, it wouldn't affect the answer. Same thing with addition and subtraction.
I see.
Whichever one comes first in the problem, that one we can do first.
It makes sense because multiplication and division are kind of related.
Yes.
And addition and subtraction are related.
Yes.
Being the inverse of each other.
Very good.
Okay.
Right, so remember, this is the order in which we would do our operation, our mathematical operations, when we have more than one operation in the problem. So in terms of exponents, we're talking about situation like a base raised to a power. In this case, 4 raised to the power of 3, sometimes 2, 4, whichever. Or roots, we're talking about square roots, cube roots, whichever roots you're given. So say the problem consists of parentheses, exponents, and say multiplication. So it means, therefore, you'd have to do whatever is in the bracket first, or the parentheses, then the exponents, and then multiplication, in order for everybody in the world working the same problem to get the same answer.
Okay.
For it to be correct.
Definitely makes sense.
All right, so let's look at an example. So here we have 3 being added to 2 squared, and we're subtracting 9 being added to 1 in parentheses.
I'm thinking, based on what you said, we're going to work what is in the parentheses first.
Definitely. So we have the parentheses. Here we have square, exponents, and addition, and subtraction. So there's 1, 2, 3, 4 different operations going on here. Now, as you said, we'd work the parentheses first.
Okay, and when I add those numbers in the parentheses, I'm getting 10.
Yes.
Although we were saying in terms of the order of operation, addition came after exponents, but because it is in the brackets,
Definitely.
we definitely have to work that portion first.
Right. So
Okay.
whatever operation is in the parentheses, that takes precedence. So
Okay.
9 plus 1 would give us 10, and that's the first operation that would have been carried out here. And then now the next operation would have been the exponent based on PEMDAS. Parentheses, then exponents. So 2 squared would give us 4. And then, so now we have addition and subtraction, as you had mentioned before.
And I can recall you were saying when we have addition and subtraction, we work the one that comes first.
Yes.
In that order from left to right.
From left to right.
So I'm thinking to do the addition first before the subtraction in this situation.
Definitely.
Okay.
So now we would add 3 and 4 and we get 7. And now we're left with only subtraction. And now this would be simplified to -3. Okay? All right, let's look at another example. So tell me the operations you're seeing here.
I'm seeing exponents, 2 to the 3rd power.
Yes.
I'm seeing a multiplication.
Yes.
I'm seeing addition and subtraction.
Good. Now, the fact that there are no parentheses here, which operation you think would go first? Because P would be for parentheses. There's no parentheses, so the next operation we'd look for would be?
The exponents.
Exponents.
That would be the 2 to the 3rd power.
That would be the 2 to the 3rd power. And 2 to the 3rd power is 8. That is 2 times 2 times 2, okay? And that would give us 8. So we have done the exponent, and now we're left with addition, multiplication,
and subtraction.
So we have
this
done.
This is awesome.
So now we're here. So which operation comes after exponent?
I'm seeing multiplication next, before the addition and subtraction.
Very good. So we'd work our multiplication before we do the addition or the subtraction based on PEMDAS. So multiplying 10 and 8, that would give us 80. So now we're down to addition and subtraction.
And again, we are seeing the situation where we have the addition and the subtraction being at the same level.
Yes.
So we do the ones that we are seeing in the order they are appearing.
Very good. So we would add 4 and 80, and that would give us 84. And now we're left with subtraction. And when we subtract these two numbers, we would get 68. Are you feeling a little more comfortable with it, Tyrone?
I'm feeling much, much more comfortable.
Yes. I think I have one more example, and I want you to tell me how you would go about working this one.
The first thing I'm looking for is the operations.
Yes.
So I'm seeing division, I'm seeing multiplication, I'm seeing subtraction, and I'm seeing the parentheses.
Good.
And as you said, we have to focus on what is in the parentheses first, because that's our priority.
Yes.
So I'm going to work with those things in the parentheses, or what we call brackets, first.
So in the parentheses, you notice there are two operations.
Yes.
Multiplication and subtraction. So,
so we definitely,
based on PEMDAS, which one would we work first?
So we still go back to PEMDAS now, and we're seeing we're still having to work the multiplication first because it has a higher priority than the subtraction.
Very good. So even in the bracket, we still have to apply order of operations. All right, so multiplying those 9 and 3 would give us 27. Parentheses still not yet simplified. So we now do the subtraction inside the parentheses, and that would give us 8. So now we're left with division. So notice, even though division here, coming first here, parentheses takes precedence. So remember, so let's finish this. 64 divided by 8 would give us 8. So remember, PEMDAS, please excuse my dear Aunt Sally. Parentheses, exponents or roots, followed by multiplication and division, and then addition and subtraction.
Okay, definitely does make sense.
All right, so I'm glad. So remember, that was just a quick review of order of operation. And if you have any questions, you can send them in. Now we're going to look at decimal places. Another very important topic in numbers.
I know a lot about decimal places.
Like what?
Like, I know the decimal point is a fixed point between the ones place and the 10th place.
Right. So what are the places? When we talk about decimal places, what places are we talking about? What comes to mind?
Tens and ones.
Okay.
That we learned in primary school.
Yes. All right. So the decimal system or decimal system, it allows us to write numbers that are large, long, or small as we want. So we can condense them to make them shorter or longer using the decimal point as you mentioned before, which is very significant. Now the digits can be placed to the left or the right of a decimal point, as you will see on the place value chart. And those to the right of the decimal point show values greater than 1, and those to the left of the decimal point on the place value chart. Let's look at what I'm saying. So here we have the decimal point on our place value chart. So these digits, greater than 1, and digits that are placed to the right of the decimal point would be less than 1.
But I am recalling in terms of the digit, where I place the digit, does it really matter? Can I put a 9 in this 1/10th place and it mean the same as putting the 9 somewhere else?
It depends on, remember, place value is very important. And wherever you place a number, the number takes the value. The number acquires a value based on where it is placed.
Okay.
Yes.
So the placement really does matter.
It does matter.
When it comes on to our decimal places
Definitely.
and our decimal system.
Yes, because it adds value to the digit.
Okay.
All right. So, so notice that, so we'll be focusing on the place value, decimal places. So over here we'll have the whole numbers, and on that side we'll have a decimal parts, which would be our fractional parts. Okay?
So these are the numbers less than 1?
Less than 1. Yes, those numbers are less than 1. All right, so let us look at an example. We're going to be rounding a number 3.479 to 2 decimal places. 2 decimal places. So if I say 2 decimal places, what should the answer have?
I'm thinking at the end I need 2 digits after the decimal point.
Right. Currently, this digit has how many decimal places?
I am seeing 3 digits after the decimal point, so I'm inclined to say 3 decimal places.
Yes. This number has 3 decimal places, but our instruction is to round it to have 2 decimal places. Now, when we round numbers up or down, we have to maintain the value. We have to maintain the value, because we don't just throw out numbers and not maintaining the value. Remember, the place value chart is important in terms of keep maintaining the value of numbers.
And as I can recall, when we were in math class, they were saying rounding off is an estimation.
Yes.
So when I'm giving an estimation, I want the answer to be very close to the original number. I don't want it to be too far off.
To be too far off, because so for example, you're measuring to get some materials to do some work at home. When you give the builder the measurement, so you give him an estimate, you don't want to buy too much or too little.
Yes.
So you want to get as close to the actual measurement as possible.
Okay.
All right. So, seeing that we only want 2 decimal places for this number, what are we going to do with the 9? Are we just going to erase it, rub it out?
I'm thinking because you're saying that we only need 2 decimal places.
Yes.
But we were also talking about approximation.
Very good.
Or estimation. So we want to find out approximately how close this figure is to something that has something with 2 decimal places.
Right, and the decimal place we'll be focusing on would be the hundredths.
The hundredth place.
Right, so we want to round this number to the closest hundredths.
So I am thinking we're going to be either thinking about something that is closer to 700ths or 800ths.
Right. So based on
place.
For this place, so based on this 9,000ths, when you think about 9,000ths, how much would 9,000 need to make it to the next hundredths?
I remember from the decimal system, we group in terms of 10.
Yes.
So if I have 9 already, I would only need 1 more to make a group of 10.
Right, and that means this 9, this number is 1 1 thousandths closer to make it 100.
To make it the next hundredth.
So that 9 plays a role in what we do
So
with
if
the
I
7.
add 1 thousandth more to this, it
Yes.
brings it to 8 hundredths.
And we want to round to the closest
Okay.
hundredths, 2 decimal
And if
places.
I was going to bring it down to the 7, it would take much more work to get it down to the 7,
Yes.
to 7 hundredths.
Yes.
Because I would have to take away 9.
Right.
And that would be
Right.
further off. And we were saying we wanted it
to be
close
close as possible.
as possible.
Yes.
Okay.
So in that case, we would have here 3.479 to round it to 2 decimal places to be
Okay, I see.
3.48.
Okay.
So we would round the 7 to the 8 because the 9 thousandths is just 100
It's 1
thousandths away.
1,000 shorter than the
Yes, than the
than
100.
what we need
Yes.
to make it.
So it's
okay.
like we're exchanging money. I give you some money
Mm-hmm.
and I don't have any change and you want 100 and say you want $197 you owe me.
Mm-hmm.
And you don't have that. So I said just give me $200.
And it makes sense because instead of you having to give me 9,
Yes.
I'll allow you to owe me the $1.
Yes, it's $1.
It's just $1 versus 9, right?
Right. So that we can
work with that.
All right, let's look at another example. So we want to do 1 decimal, please. So we have 7.536 to be rounded to 1 decimal place. Now this number has 3 decimal places and we want 1 decimal place.
Ooh.
So we're looking at the 10th column.
We're looking at the 10th place. That's,
Yes.
Okay.
That's where our 1 decimal place will be, the 10th column.
And I am seeing a 5 in the 10th place.
Yes.
Right? So what I'm wanting to determine now, in order to get it to the closest 10, I'm going to have to decide whether it's going to be 5 tenths or 6 tenths.
Yes, because the next tenths after 5 tenths would be 6 tenths. And in the hundredths column, the hundredths, those numbers would not be a part of the 1 decimal place, but they play a role
In deciding
the value that we maintain,
Yes.
keeping the value.
Okay.
So 3, as you mentioned, it's 10. Decimal system is out of 10, multiples of 10. So 3, which would mean we'd need how much more?
7 more.
We would need 7
But
more
that's too
hundreds.
much.
That's too much.
It's
So-
better I owe you the 3 than you have to give me all of 7 more to make
Right.
it up.
So in a situation like this, when it is taking you more or less than a half, you don't increase this because it's taking too much more. It would need 7 more to make this 6,
To make that 6 tenths.
to make it 6 tenths to the closest, right? So in this case, we would let it remain as 7.5. Good? It would remain at 7.5. However, if this 3 here was, say for example, 5 or more, we could round to the next place amount, which would be 6.
Because it would be closer to the next
Right.
tenth.
It would be closer to the next tenth. So think of it as on a number line, right? So it would be closer to the next tenth. So 5 would be halfway, halfway between the tenths.
Okay.
Right, good. All right, so let us look at a question on the CSEC question paper, May 2018. And I'm sure you're familiar with this question. You have seen them regularly on your papers. So let's see, here we have 2 operations and we're being asked to use a calculator or otherwise evaluate each of the following, giving your answers to 2 decimal places.
Okay. I'm thinking these people at CSEC are trying to trick some of our students.
Why is that?
Because initially, before we learned about order of operations, we would just think about subtracting that 5.23.
Okay, because what you see subtraction come before
Yes.
multiplication.
But we know better.
We know better.
We know better because now we are seeing a multiplication and a subtraction.
Yes.
And we know that the multiplication takes a higher priority. Therefore, we would have to work that section first.
We would have to multiply first based on the order of
Yes.
operation, PEMDAS. So remember, don't just, as you see the question, you just jump into it right away. Remember all that you have been taught. So we multiplied first, and we would have gotten 48, multiply 5.23, and 9.34, and we got 48.842, sorry. Now the next operation was subtraction. So now we would subtract 48.8482 from 73.18, giving us 24.3318. No, it didn't stop there. It says give your answers to 2 decimal places. How many decimal places does this have?
I'm seeing 4 decimal place. And
Yes.
if I did remember this, I would leave it as that. But as you said, they said we needed to give it in 2 decimal places.
And we don't want to lose our marks because we get marks for following both instructions.
Yes.
So 2 decimal places, so it means we need to keep these 2 threes, 1, 2 numbers, 1, 2, 3.
Those 3s after the decimal point. We definitely need to keep those 2 places.
Keep those 2 places and get rid of the 1 and the 8. Now, before we throw away the 1 and the 8, examine the 1. How many more would we need?
That's in the thousandths place, if I can recall, right?
Yes, that's the thousandths place.
And I'm going to, in order to make that to the nearest hundredth, I'm going to need to add 9 more.
And that's a lot.
That's a lot.
So we can just get rid of the 1 and the 8. All right? And that would give us 24.33. Good. Now, we have another one quickly to look at. Now, same paper, and this is part 2. Now, we have 2. How many operations, Tyrone?
I'm seeing 2 jumping out at me, but I know that line is supposed to mean something.
Okay.
But I can't quite recall what that line between that 3.12 squared means again. Can you remind me?
What does this part looks like what?
It looks like a fraction.
Yes, it looks like a fraction, right? And as you mentioned about the line means we're going to be dividing the numerator by the denominator.
And that's what we're doing when we're doing fractions.
Yes, we're going to be dividing.
We're dividing into parts.
Yes, we're dividing into parts. So it means, therefore, that whatever we get for the numerator, we're going to be dividing that by the denominator. So we have exponents, division, and addition. Based on the order of operation, PEMDAS, we would work which one first?
I'm thinking starting with the exponents.
Exponents, good. So that's 3.1 squared, which would be 3.1 multiplied by 3.1. The exponent tells you how many times you would do that. And when we multiply that, we'll get 9.61. So we have done the exponent. What's next?
Division, if I can recall.
Yes, division. So we're supposed to divide the numerator by the denominator. So when we do that division, we'll get this long number.
That's a long, long, long number.
Yes, 9.61, which was a new numerator, divided by 6.17 will give us this long, long number here. 1.5575364667747. Now we see these long numbers on the calculator. And then the next operation is supposed to be addition. That's the final step for the operation. And when we add them together, we're getting 2 points. So, and the next thing to do is to remember 2 decimal places. 2 decimal places. All of these need to go. So we want 1, only 2, 1, 2, 6, and 7. So the other numbers need to go. But before we throw them away,
there's a 7 in the thousandths place
7
again.
in the thousand place. And we would need how many more thousand?
3 more.
3 more, which is closer, which would give us closer to the hundredths, so we can round up. And when we add that 1,000th, we would get 2.68. All right? We're going to take a quick break, and we'll be right back with more mathematics. Welcome back to class time. We've been reviewing numbers, so let's continue.
Thank you, Nikisha. We'll jump straight into significant figures. What is meant by significant figure? Nikisha, what do you think?
I'm thinking digits that have value, that are important, necessary to the value of the number, the whole number.
Yes, so that word significant means that it's important for some reason, right?
Yes, yes.
Okay. So significant figures are the number of digits in a value, often a measurement that contributes to the degree of accuracy of the value.
Right.
In other words, significant figures are used to make a measurement precise.
And we see that word precise
Yes.
coming up when we were talking about decimal places earlier and maintaining value when we were rounding.
Yes, maintaining precision is important for mathematicians.
Yes.
So how do we determine significance?
All right.
We know all non-zero digits are going to be significant. So that falls into 1, 2, 3, 4, and so on.
So numbers that are not zero.
They are not zero.
Digits that are not zero, okay.
Any zero between two significant digits are significant.
Okay.
In this case, you're seeing a zero between the 7 and the 3. So that digit in that place makes the digit significant.
So this zero now becomes significant.
Yes, because...
And this one?
Yes. Now, those two digits are significant because of the place that it falls.
Right, it falls between two non-zero.
Between two non-zero digits.
Okay, good.
And leading zeros are not significant, as you will see here.
Okay, so I noticed that they're leading,
Leading, meaning
the
they're at
number,
the front?
At the front.
Yes.
So because they're not between any significant number at this point where they are leading, they are not significant.
They're not significant.
Okay. So zero is all over the place.
So zero is all over the place. Sometimes it is significant and then sometimes it is not, right?
Okay,
So it
okay.
is for us to know when it is significant and when it is not.
So seeing that zero significant sometime and it's another time it is not, why we need it sometimes? Why is it significant sometimes?
As it regards what we had discussed earlier, it has to do with the precision that we are trying to accomplish.
The value,
right?
okay.
So as we had mentioned before when we were doing estimation, we're trying to maintain some values.
Yes.
And the value of the digits.
Yes.
So when it is that the zero affects the value of the digits,
yes,
and it's important to preserve in the value of the digits, then in those cases, most times it becomes significant.
Okay, very good.
Trailing zeros in a whole number are significant only if a decimal point is present.
Okay.
As in this case. Because we want to, say for example, I am rounding off and I had 49.999 to the nearest tenth.
Okay. Yes.
In order to show them that this number is to the nearest tenth, and to preserve the value of that tenth place, I would need that digit there.
That zero right here?
Yes.
Okay.
As opposed to just writing 50,
yes,
which would not be to the nearest tenth. It would be to the nearest whole number.
Yes.
So we're seeing in terms of preserving the place value
yes,
as another function, as the main function of that zero.
Good.
Finally, a final zero or trailing zeros in the decimal portion are significant.
Okay.
And it links to what we were just discussing earlier.
Yes.
Because in this case, obviously, this number is expressed to the nearest hundredth.
Yes. Or two decimal places.
Or two decimal
now,
places.
As you mentioned before, Tyrone, in terms of zero playing an important role in maintaining the value of the number. So if for example, we want to show 700 and 703. So if that zero is not there, it would be 73.
73.
Yes, it would 703.
And it wouldn't have the same meaning.
It wouldn't have the same meaning and it wouldn't have the same value. So zero is very important in
in that
maintaining.
case, and we are seeing in that case where it falls between two significant figures.
Yes.
So it would be important in preserving the place value. Okay, so we're going to be looking at some figures and we're going to determine if they are significant or not, right? And this just gives us a summary of the cases in which the digits are going to be significant and when they are not going to be significant. Firstly, you're seeing this first one before the decimal place.
Go back again. All right. These three.
The first one before the decimal place.
Those are cosmetic.
It serves a cosmetic purpose because really and truly, most persons, I tend to write it sometimes, even without that first zero in front of the decimal place.
Yes.
Next, as we had discussed before, the other leading zeros also really don't affect
The value here of the whole number. They're not significant here.
they're not significant in this case.
Right. And in here also, these zeros between these two non-zero would be significant. And these two at the end, as you had mentioned before,
Are significant.
That they're also significant.
Yes. Okay, how do we write a number to a given number of significant figures?
All right.
So let us look at this number. And we want to get this number to two significant figures.
3,487 to two significant figures. So it means on the board now we have four significant figures. All of these are non-zeros, so they are all significant, and we want to write 3,487 to two significant figures. So doesn't mean...
What are you thinking, Nikisha?
Does it mean we're just going to throw away the 8 and the 7? So we have 34,
35.
Let's see.
Let's see what would happen if we put on 30.
On the number.
That was the original number.
Yes.
And that is the estimate
Yes.
after we did the significant figures.
Yes, that don't look right because this is 3,487 down to 35.
No, man, that would be a good estimate.
No.
If I needed 3,400 and something tiles and I gave my contractor 35 tiles.
That's way, way below. Way below.
So definitely 35 would definitely not be a good estimate.
No, because we want to maintain the values in the thousand. So what could we do?
I'm thinking we need to preserve the value.
Yes.
So I'm going to need those.
So just as how with the decimal places, notice that this 8 here, moving up in groups of 10, it would take what? Two more groups of 10 to make to the next 100.
To the next 100th.
Right. So then we can add on to that to make it now 500ths. So now this would be 3,487 written to two significant figure as 3,500.
And let's evaluate that. Let's see how far or close it is to our original. Would it be acceptable?
Yes, definitely, because this now is closer to the 3,487 than it is to 35 going forward.
Okay, let us look at this one.
This is your 20 minutes.
And let's look at it to...
Four
significant figures.
Yes. All right, so we would have 1, 2, 3, 4. So we know we don't need 1, 4, and 3. So,
Nikisha,
yes.
that 0, because that 0 is a issue. Do we consider that significant or not?
Yes, it is, based on what we want to maintain the value. Plus, it is between two non-zero digits. This 0 is significant. So we would count it as a part of significant figures.
And if we took out that 0, it would change the value.
Change the value of the whole number.
The 5 in particular,
Definitely.
that is after it.
Yes.
Okay. So
that
to
would be...
four significant figures, that would be 3.605.
Good.
Okay. Let's write a few of these numbers to a given number of significant figures. Let's see if we can get this 8,952 to one significant figure.
Right.
What are you thinking, Nikisha?
It can't be 8. It can't be just 8. It can't be just 8. Because I'm coming from 8,000. So it would mean I need to have a number in the thousands.
In the thousands.
Yes.
And we know, based on working with numbers, that this is very close to 9,000.
Yes.
Right? So if it is we wanted an estimate, 9,000 would
9,000 would be good.
Would be good.
Yes.
Let's see this one to 3 significant figures.
All right. So the first 0, I know, would not be significant because it's just there for cosmetics and it's a leading 0, right?
Yes.
So I wouldn't start counting from that 0.
So which one would be the first significant digit?
7.
Okay. So we're counting 7, 0, and 4. But what about that 5 that comes after the 4? Does that affect it?
It would affect my rounding and the value because it's halfway. That 5 would be halfway to the next hundreds. So that would give us
0.705.
Good. And the other one to 2 significant figures, starting from 6, 1, 6, 1, 2. So I need 2 numbers, and the 2 in the hundreds place, it would need
far.
8 more.
Yeah, it's too far from the nearest.
It's too far from the nearest tens.
It
would need 8 more to get there. All right, good. So let's look at a CSEC question.
All right, let's see what's happening here. So we get to write the following: 3.142 times 2.236 squared, and we're giving the answer to 3 significant figures.
Yes. So notice we have 2 operations, Tyrone. We have multiplication and we have exponents.
So I'm seeing CSEC integrating the 2 concepts, both significant figures and order of operations.
Very good. So we need to work the exponents first.
Okay, so once we square that number, we will get this as our solution for the square of the value.
So after doing that, we can now multiply.
And then we can now multiply that by the 3.142.
And that would give us 15.709044. But yes.
Very long number.
Very long. So now we write that to 3 significant figures. So counting from the left, 1, 2, 3.
1 is significant, 5 is significant, and 7 is significant.
So we need to get rid of these numbers.
And we're going to see if that 0 affects the number.
Right.
No, it's too far from...
It's too far.
It's too far.
So we would write...
So our final number to 3 significant figures would be 15.7.
Yes. All right. Go in quick.
Okay, so let us do a quick recap of fractions.
No, Tyrone, I'm looking at this picture. I remember when it was taken, it's when we went to visit Auntie in country the last time. And as usual, you get more than me.
But of course, I'm Auntie's favorite.
Look how much sandwich on your plates. You have 4 sandwiches on your plates, and I only have 2.
But wait, it don't look like the same size sandwich that is cut up into different parts. Look at it carefully, Nikisha. Look at it carefully. Is it the same?
Now that you mention it, yes. It's the same 2 breads put together. This one cut in 4, and your one cut in 2.
Okay.
But it's the same.
So Auntie gave us the same amount.
I mean, the things that me get more.
Okay. So let us look at some of the core fractions concepts that you would need to know. Firstly, you would need to know how to rewrite fractions as equivalent fractions, right? And we're looking at these 2 examples. Firstly, we're going to be reducing the first fraction, and we want to know how could we possibly reduce this to an equivalent fraction to the lowest term.
An equivalent fraction mean what?
Something that has the same value.
Okay. It has the same value, but
in terms of proportion.
Okay. And so therefore we need to maybe multiply to get or divide, whichever operation.
But I want to express it as something in a reduced, in a smaller format. To the lowest format.
Okay.
And I am seeing where they probably have a common factor, because I know that 4 can go into can divide into that 8.
Yes.
And 4 can also divide into the 12. So let's see.
So we're going to simplify them.
So 4 divided into the 8 gives us 2. And 4 divided into the 12 gives us 3, sorry.
Yes.
So that would give us 2/3 as the reduced format. So,
And that's equivalent to?
and that's equivalent to the 8/12.
Okay, good.
And visually, if we would represent them, they would look the same.
Yes, yes.
All right, let's see what would happen if we wanted to express this as an equivalent fraction with the numerator being 15.
Okay.
Okay, so if I want the numerator to be bigger and I wanted it to be 15, I would have to multiply that numerator by 3.
Yes.
But Nikisha, if I multiply the numerator by 3,
You'd have to do the same thing to the denominator.
Why?
Because you have to preserve the value.
okay.
And whatever you do to the numerator, you have to do to keep the balance.
And then multiplying by 3 on the numerator and multiplying by 3 on the denominator is the same as multiplying by 3/3, which is 1.
Yes, 1.
Okay. So
you're saying 5/9 is equivalent to 15
27.
27s. Good.
Okay. So let's see what would happen if we're adding fractions and subtracting fractions. And we have these fractions to work with.
So the denominators are different.
The denominators are different. So Nikisha, can I just go ahead and subtract those?
No, we can't go ahead and subtract them. We have to, as you mentioned before, equivalent. This is where equivalent fractions plays a vital role in adding and subtracting fractions. We have to create equivalent fractions. So the denominators are the same.
So what you're saying, in the current format, no, I cannot just subtract 3 from the 5 and 1 from the 2.
No, because they're not the same.
Okay, so we want to express them in with the same unit.
Yes.
Being in the same portion, equal sizes.
Right.
In order to do the subtraction.
Yes.
Right?
Correct.
So because these are in 2 different sizes in terms of the fractions. So what would be the common fraction in terms of the denominator?
I'm thinking 15.
Okay, I'm seeing 15 as well, because I'm thinking 5 can divide into the 15
So that
and
would
3 can divide into the 15.
Right. So that's the smallest number that both of them can divide into. 50.
But could we use another one?
Which one? Are you thinking 30?
30?
No, we want to use, it could work, but it would mean more work.
It would be more work for us, so we're trying to use the lowest one.
You're right.
And we have a special name that we call that lowest common denominator.
Or multiple.
Or multiple, right?
Of 5 and 3.
Of 5 and 3.
Yes.
And that's what we call LCM when we were doing math. So once it is that we rewrite these fractions as equivalent fractions, this is what we're getting.
So this fraction here is equivalent to this one.
Multiplied by?
And multiplied by 3. And multiplying this fraction 1/3 by 5 would give us this equivalent. So these 2 fractions are equivalent, and 2/5 and 6/15 are also equivalent. Now they have the same denominator, so it therefore means that now we can subtract. 6 subtract 5 would give us 1. So 6/15, and we take 5/15 would give us 1/15. All right?
Okay, we are going to our final break. When we come back, we'll wrap up things. Soon come.
Hi there, I'm Simon Preston from TVJ. Thank you very much for watching our YouTube channel. To see our latest videos and also to see live events, click here. To see our full videos on onespotmedia.com, click here. Thank you very much for watching.
Welcome back. All right, let's continue.
Okay, we will do a quick recap of multiplication and division, and then we'll move into a CSEC question. Okay, so when it is we are multiplying fractions, this is one of the easier concepts for most students because we just go ahead and multiply the numerators. So in this case, we would have 2 times 5 to get our new numerator to be 10, and 3
And
times
7.
7 gives us 21.
So we don't need to find any equivalent fractions.
Yes, we don't need an equivalent fraction
All
for
right,
multiplication. So that's fairly simple for most persons. But what happens when we are going to be dividing a fraction?
By another fraction.
By another fraction.
All right. So it therefore means, so when normally we say we flip the fraction, we flip the second fraction, we change the sign and flip the second fraction. But what we're really doing?
Basically, it is we are multiplying by the reciprocal. And that's a big word, but basically it's going to be the inverse of a fraction.
All right. So you have multiplied by the reciprocal of 3/5,
Yes.
which would be 5/3.
And then we'd go and do the same thing as we had done before. But
Like here.
Like here.
Oh,
But in this case, we can reduce, we can simplify by dividing by 3 and
I see where you were going.
by
there.
3. Okay. So let's look at one of the more complex.
All right. Go through, go. So we're trying to
CSEC
find...
questions. Okay, here. So Nikisha, let us look at this question.
Right, so we have subtraction of these two mixed numbers and we have division here.
And we have parentheses.
And we have parentheses again, order of operation.
Yes. So we're linking in back the order of operations that we spoke about earlier, and we're integrating that into the fraction concept.
Good.
So Nikisha, where would we start first?
Well, we could either work with the whole numbers by, or if we could just change the mixed number to improper fraction, we're starting with the parentheses here. So we
Okay.
could change the mixed number to improper fractions, or we could take out the whole numbers if you want to.
Okay. But we definitely need to start with the parentheses
We
because
definitely- yes,
of
order
what
of
we learned from order,
Order
of
of
operations.
operation, definitely.
So I'm thinking about converting to
Quickly.
mixed fractions,
All right, mixed numbers.
mixed
So,
numbers.
so changing the mixed numbers
To
to
improper.
improper fraction,
Yes.
we would get 4 times 3 plus 12 give us, and 1 give us 13. 5 times 1 is 5, and 2 give us 7. So we have 2 new fractions
No,
here.
as improper fractions.
And now we need to find create equivalent fractions.
With a common denominator.
Common denominator. The lowest common multiple for 3 and 5 would be 15.
Yes.
So now we have created equivalent fractions by multiplying the first
Multiplying
fraction.
the first fraction, the numerator and the denominator of the fraction by the same number, which is 5. And we get
65 15ths.
And then the second fraction, we multiply that numerator and denominator by 3 to get
21 15. So now we subtract. So after subtracting 21 from 65, we get 44. So we have
Okay.
finished with the parentheses.
and we would have finished that section.
Yes.
So, Nikisha, where would we go next?
We would now divide the result of these subtraction by 4/15.
All right, so let's put that up.
And we know when we're dividing by a fraction, we get use the reciprocal, multiply by the reciprocal.
Multiply by the reciprocal.
So we would maintain the first fraction and multiply by 15/4. And that would give us, so we could
We can
reduce,
simplify
sorry,
by
before,
dividing by 4 and dividing these
by,
by
15,
15.
and that would give us 11.
and that gives us 11
All right,
divided by 1, which
is
is the same as 11.
All right, good. All right, so let's move into a different segment. All right. So we want to look at the calculators. Using the calculators. As you know, there are different brands of calculators out there. Here we have the Texas Instrument, the Casio, we know the Sharp, and all of that. And they all have some of different features.
And different functions, and they operate differently.
But generally, they have a set of functions, all of them. And then we're going to look at a few of those. So the plus sign, the minus sign.
And we use the minus sign in two ways. We use it for negation,
yes,
or to change the sign of the operation, or as well as we use it for subtraction.
Okay. Now we have this. I want to point out this one here, because sometimes we don't have the square, the
yes,
exponent there, and that can be used to raise the power off. So you would input your base and then click on that button with that inverted arrowhead, and then put your power that you would want, and it would do the calculation.
And it functions almost the same as if we had the y to the x functions.
Right. Some calculators will also have SQRT, or the square root sign. So some calculators you'd have to put the square root sign first, and then the number you want to find the square root of, or you may have to put the number first and then the square. It depends.
So Nikisha, how do I know?
You just have to try it. You get your calculator, you just have to test to see how your calculator works.
So that means I can't borrow a friend's calculator on the day of the exam?
No, don't borrow the calculator on the day of exam, because you might run into problem not knowing how to operate that calculator.
Okay, so we have to practice using the functions and know how your calculator operates before you take it, especially into an exam.
Definitely. All right. So now we have the trig ratios.
Oh, for the trig ratios, how would I get, say, the inverse in particular?
All right. So if you want the inverse function, if some calculators you may have to press second or shift, and then you'd press the sign button, because the inverse is usually on the calculator itself and not on the button. And then you get the inverse. You'll see it on your screen, the sign inverse on your screen, and you'd input your number, your angle size, following that. It could be the other way around. So as we
yes,
said
I would
before,
have seen some calculators where you enter the numbers first before you actually enter the operation, like the sine and the cosine.
All right. So basically, we looked at order of operations, we looked at rounding off decimal places, and we looked at
fractions,
simplifying fractions. And we're hoping that as you go forward doing your exams, doing your classes, you'll remember that the main points that we would have shared.
Unfortunately, that's all the time we have for this session, but you can catch a repeat on JNN at 4 p.m. and the highlights of this week's program are also on Saturdays between 1 and 4 p.m. on TVJ and on video on demand on One Spot Media.
Remember our new times, Monday to Friday, 9 a.m. to 10 a.m. And also, don't forget, the School Time channel, 24-hour learning, is back on One Spot Media. Until tomorrow, keep safe.
Hi there, I'm Simon Preston from TVJ. Thank you very much for watching our YouTube channel. To see our latest videos and also to see live events, click here. To see our full videos on onespotmedia.com, click here. Thank you very much for watching.